Hello everyone. So, today we are going to be going over Python loops. So, Python loops is essentially like the definition of a loop. So, perform something over and over again. Over a certain number of times you tell it to loop over. Whether this be something like performing a calculation over and over again, or doing some sort of action over and over again. That is essentially what the purpose of a Python loop is. Now, loops are very useful in many situations, and we might go into some of the specifics today, but for today we're basically just going to go over the basics of loops, why you would use them, and how they work. So, without further ado, let's move on. So, iterations. Iterations is essentially just repeating something over and over again. Whether this be this can be anything, obviously, and this is essentially just the English definition of it. And any sort of iteration involves repetition. And what we're talking about here in loops, it's essentially just going to run over the same code block over and over again. So it doesn't necessarily have to repeat the exact same process over and over again, because you could have, say, an if statement within the loop, and so that if statement would then enable the loop to run different actions every single time it iterates. So essentially, what a loop really does in Python is it allows for a certain code block to be run multiple times over. So, given that English definition, we can kind of find out examples of iteration in our daily lives. This can be anything from like something that we kind of just do as part of our schedule, like going to school, going to a classroom, going somewhere to eat lunch, going somewhere in the hallway to talk to friends, a certain activity you do after school, even this class, because it always happens on Tuesdays and Fridays at 5 o'clock. And this is kind of iteration in our daily lives because it's happening over and over again, and obviously there's a certain number of times we can do it. Like this class goes on for a period of 5 weeks, right? So this kind of shows how iteration is present in our daily lives, and this probably should give you a better sense of exactly what iteration is. So, just like last presentation, we're going to go over the similarities between like the math and programming. So we're going to go over iterations in math. So, although this isn't necessarily as blatant or outright as some of the examples we gave last time, iterations in math can be anything like trying to find a prime number. So you need to test every single integer greater than 1 and less than that integer to make sure that that number is a prime number. And this can be anything from, you can be like rather inefficient, say like you're doing a program, you can just write it as every single number. But if you were to be more efficient, you would test numbers that you already know are prime. So iterations in math can be called either conditional or not conditional. So conditional iteration means that you stop to iterate if a certain factor is found. So this is kind of like the if statement within a for loop. And if it's not conditional, we need to find all of the factors of that number. So this kind of shows how iteration in math occurs, and once we understand how it occurs in math, then it's much easier for us to implement in programming. And just like last time, computers compute, which essentially means that they do a lot of math. And so the same iteration processes in math apply to everything in programming. So I'll let you read over this slide. Now that we have a good idea of iteration in math and in real life, we can now move on to programming. So, iterations in programming. So, iterations is very, very powerful, right? So, the special thing about computers is that, unlike humans, the number of times a computer can iterate a certain um, there is no limit for how many times the computer can iterate, essentially. Yes, it will take the computer slightly more time, but the computer is miles more efficient than a human would. And the reason for this is because, well, the computer is able to do multiple calculations at once. And as a result, it can work probably 100 times, 1,000 times faster than a human brain. And that's no exaggeration. So, essentially, in order for us to try and find out if this huge number over here is a prime number, we would need to take every single prime number that's less than half of it and make sure it's not divisible. Now, this would take a very, very long time for any human to calculate, as this number is like 28 million, right? But for a computer, all you need to do is write like 3 lines of code, and essentially just divide that number and iterate through every single number that's less than half of it, and not equal to 1. And in the case that it is divisible, or the percent feature or the modulus feature is equal to 0, then the loop cuts out and it returns that it is not a prime number, right? So that kind of shows how iteration in programming can be a very, very powerful feature. Now, iteration can also bring up another, I guess, part of programming. And this kind of part of programming is going to be time complexity. Now, I talked about time complexity in the last presentation a little bit, but we're going to go into it in slightly more detail this time. And so, essentially, what time complexity means is basically it is how long the program takes to run. Now, if in the case that there is something like a input and there's an output, then that means that it can vary, kind of. And so that's where we use something known as big O. And big O, essentially, now this is a kind of an abstract concept, so I won't go into too much detail with it, but essentially what big O is in relation to the input that you put in, what is going to be the output time, right? So say you put in this huge prime number, then the big O of this prime number would be known as O of n, right? Or it repeats over this program or takes n long to run. And so obviously it can vary within the program, but the most time consuming part of the program is going to be running through loops. And the programmers, the people who developed this idea of big O, kind of understood that. And they're like, well, we kind of want to see how long will it take for this program to run this entire function. And so instead of having to try to calculate it out using like actual time, instead we can just create an abstract time concept. And so that's how time complexity, or big O, was created. Alright, so we ran a test, and there was we ran it on like our laptop at home, like I believe a i5 core, which is a pretty old computer, and it took around 6 seconds to find out if that number was a prime number, and it is a prime number. And so here is like the link for it. So I'll post that in the YouTube chat real quick, and you guys can try it out yourself. Open it up in your Python IDE, and you guys can run it. And so basically, what this means is that the computer, like as I said before, it's like 1,000 times faster than a human brain. Actually, looking at this number, it would probably be even faster than 1,000 times. So, point is that the computer is very, very good at doing brute force, or essentially the stupid way in. And the reason why it can use the stupid way is because it can do the stupid way so fast that it's faster than the smarter way. And typically in math, you always want to go with the smarter way. But in programming, many times it's much easier to write something, say, that doesn't have as much logic within it, but since the computer is so fast at calculating, it won't affect the output time. And so as a result, there's no need to try and simplify it. So, let's move on. So, there are going to be two main types of loops in programming. So, these two main types of loops are for and while loops. So, this is how you write a for loop right here, and this is the code block within the for loop, right? So, essentially what's happening is, I'm just going to give a brief explanation. We're going to go into more detail later. But the for loop in this sequence is going to go between 2 and num. So essentially what this means is that I is going to equal to every single integer between 2 and num. And for every single iteration of it, it's going to run that kind of that code block. So this is kind of how a for loop is written. So I'll let you guys look at that for a second. Alright, so now that we've gone over for loops, we're now going to go over while loops. So as you noticed in for loops, the only condition that you could put in over here was the range, right? But in while loops, you have a slightly more, I guess, flexible condition spot. So this condition, while this condition is true, the loop will continue repeating. Now, you could use it like a for loop, and you could do for every single number less than 9, and it can increment up to 9, right? It'll print. But you can have many, many other conditions. And this can be anything that returns a Boolean value. So this is why the while loop can sometimes be a little more flexible than the for loop. Although, if you are trying to iterate, the for loop is oftentimes a lot better for that, because it will increment the number for you, and oftentimes it's more flexible in the incrementation matter, right? So that's kind of those two types of loops. So I'll let you look at that first. I can't speak English. I'll let you look at that for a second. Alright, so like I said, while loops is very, very flexible, right? And as long as that condition is Boolean, then it will continue running. So that's why you can actually just go ahead and stick a Boolean value in there. So while true will essentially just repeat infinitely. And this infinite loop will occur until it's terminated. And this can be either an error that the program will give, a cut line that your code block has, or you shut your computer off. So essentially this infinite loop, if run improperly, can actually be a little damaging to your computer. However, in IDEs, programming languages like Python, where it's a fairly controlled environment, it proves no danger. However, if you're programming with a language that has more direct access to your computer, like C++, then you need to be more careful with this stuff. So this wraps up our presentation, and so we're going to move on to a couple of the websites. All right.
Okay, so with the while loop, you can execute a set of statements as long as a condition is true. Okay, so basically, in the first example, it says print I as long as I is less than 6. So it says I is equal to 1. So while I is less than 6, print I. So what this means is for any number less than 6, it will print the number out. So it says for 1, 2, 3, 4, and 5, because 6 is not less than 6, it will print it out. And the I plus equals 1 just means to increment by 1 every time. So once 1 is done, it will go to 2, and then it will test 2 out. And then it will do it until the condition is false. So the note here says to remember to increment I, or else the loop will continue forever. As Matthew said in the last slide, the infinite while loop. So if you don't increment by 1, you'll have an infinite while loop. So with the break statement, you can stop the loop even if the while condition is true. So in this example, it's the same thing up as before, where while I is less than 6, you print it out. Except here it says if I is 3. So once it hits 3, it will stop and move on to the next one. So if you try it yourself, you'll get 1, 2, 1, and 2. And then it will stop at 3 and then move on to the next statement. So here's the continue statement. It's kind of like break, but there's a small difference. So with the continue statement, you can stop with the current iteration and continue with the next. So this is the same example as before. So while I is less than 6, but here, once I is equal to 3, it will continue to the next one. So if you try it yourself, you'll get 1, 2, 4, 5, 6. So it will basically skip 3. So it just continues on to 4. And here, it's kind of a combination of the else statement and the while loop. So you'll have I equals 1 while I is less than 6, print I, and then you have the increment by 1 every time. But once it reaches 6, so because 6 is not less than 6, so the condition is false. It will do the else statement. So I is no longer than 6. So basically, once it's false, it will use the else statement.
This is kind of the exercise at the end, so you can do this yourself. So we can see that this is kind of a very simple while loop. So if we go up here, we can see, not up here, over here, this is what it's going to look like. This is the solution, I guess. So you just print while and the colon over here. So all we need to do is just type while and the colon. And that is going to be your answer. Alright, so next is going to be for loops.
So a for loop is used for repeating a sequence. We'll start with this for loop, which is about repeating how many fruits are in the list, which are apple, banana, and cherry. So the for x in fruits means that for every string in fruits, it will print it out. So it will print apple, banana, then cherry. Next to, so now there's looping through a string. Strings are also, like as you can see here, strings are also repeatable. And you can print out each letter in the word banana because it's a sequence of characters. So to print out every single letter, I'm not gonna spell it out because it'll take too long. So next is a break statement, which, as Pranav said earlier, it can like break a for or while loop. So for for loops, it will just once it reaches the if x is equal to banana here, then it will stop the loop and it will just print out apple. It won't go and repeat down to cherry. Next is a continue statement, and Pranav also covered this too. It will stop the current iteration of the loop and then go to the next one. So in the example, it would say, the code would do, for x in fruits, it will go say banana. Banana is not equal to, apple is not equal to banana, so it'll print apple. And then next one, it'll say banana is equal to banana, so it'll continue, and then just print banana and then stop. So the range function is it'll return the sequence of numbers in the loop, starting from 0 and going to the number that you set. So it will do the for loop from 0 to like x times. So in the example, for x in range 6, it will print x 7 times. Wait, 5 times, sorry. Then you can also add the start parameter to make it start at a different range. So instead of just starting from 0, you can start from 2. Then you can even do increments. So instead of going from adding 1 to each loop, it's adding 3. So 2 to 5 to 8 to 13, so on. The else keyword in loop specifies a block of code to be executed when the loop is done. So if the for of so for x in range 6, it will print x, and otherwise it will print finished. So a nested loop is basically a loop inside of a loop. The loop in the inside will be done first before the loop on the outside, so it has priority. The inner loop has priority. So finally, the pass statement. If you have a for loop that doesn't really have anything in it, you can put a pass statement to avoid getting an error. And then this is like a little exercise with loops.
Alright, so this exercise, you guys can do it yourself. I'll give you guys 1 minute to do this. So this is like the first example. So is x in fruits. That is going to be your answer. Alright, so final website for the day is Geeks for Geeks. So this again is a very good source, and essentially we're just going to be doing a quick kind of review over this. So the while loop is going to be written like this. So just keep this in your brain and make sure that whatever variable you have in here, whether it's incrementing or something, you have to define it outside, because if you don't define it outside of it, then it won't know what in the world count is. So you cannot define it inside of here, right? So you also need to make sure that when you increment, you make sure you print it out like this, because if you say like, you can't try and hard code the increment in, that just won't work, because you can't hard code incrementing. So after this is run, it goes from 0 to 1 to 2, and so it runs over 3 times. So it prints out Hello Geek 3 times in a row. So the else statement in loops is kind of like the if statement and else statement. So essentially, while this condition is true, it will execute this. But in the case that it is not true, then it will execute this. And so the Python program that is able to illustrate that is written here, and we can see after it reaches 3, then it prints in else block. Finally, not finally, sorry, next is going to be the single statement while block. So like pretty much all things in Python, you could squeeze it all onto one line. Now, I would not recommend this, as per usual, because doing this will be very confusing. Because you should always have it compact, but you should never have it too compact, essentially what I'm saying. So keeping it all on one line is not quite a good idea, as it's kind of hard to read. So next is going to be the for loop. So this is going to be the for in loop, and so essentially it's just for I or for x in range, and you list all the parameters. So the parameters can be just one number, and it can be 2 or 3, and each one of the parameters has its own meaning, right? So given the meaning, that's what number you would put in, or what parameter you would put in. So this is kind of a program that shows the parameters and work. So let you guys look at that for a second. Right, so this was quite a long program, so hopefully you got it. So next is going to be iterating by the index of sequences, so iterating through this collection right here. So as we can see, it will iterate through length of list and will print list index. Fairly simple. This can be a little confusing. This essentially just means the length of the list. Next is going to be using else statements in loops. So the else statement, else in for loops. So it's just like else statements in while loops, except it's in for. So when when the for loop is done iterating through it, then it'll do whatever the else statement has. So you can use the loop for user-defined iterators, and this can be like this. And so essentially this is known as a nested loop, right? So I talked about how a single loop would be a time complexity of O of n, right? Well, a nested loop would be O of n squared. And the reason for this is because within each one of the increments within that loop, it has to do it all over again. So essentially, it's doing it n squared times. So this is kind of how the nested loops works, and there's nothing too special about them. Next is going to be loop control statements. So loop control statements are kind of just anything to kind of it's kind of like an if statement within a for loop, and so this can be going through each one of them and printing if it meets a certain condition. Next is going to be break, and break is essentially just breaking out of the loop. And the next is pass. So we went over these two already, so I'll let you guys look at that for a second. Alright, so now that you guys have had a little to look at them, so that looks like it's the end of the article. So if any of you have any questions, so we're just going to go to coding bat, and you can see there's the warm-ups, there's lists, so I recommend going through lists 1 and 2 for this, as many of them have iterations going through them. And the reason why we went through collections last time is because collections are what people mostly iterate using, what most people iterate through. And because collections have lots of data, and many times you want to access all of that data. And the most efficient way to do that is using a loop. So, if you have any questions, please remember to just put it in the chat. And if you don't have any, then thank you for watching. And alrighty. Looks like nobody has any questions. So thank you everyone for watching, and see you next time.